Hi, QCE mentees. We're just going to run through this mathematical induction question from a specialist. So yeah, starting with mathematical induction, what we always do is that we prove that this function up above, right, this function we see over here is divisible by 25, and we prove that's true for P of 1. Yeah, or n equals to 1. So let's do that first. Let's see here. So we have our left-hand side, which is going to be 2 to the power 1 plus 2, 3 to the power 1 plus 5 multiplied by 1 minus 4. 2 to the power 1 plus 2 is going to be 2 to the power 3 multiplied by 3 plus 5 minus 4. This is going to be 8 multiplied by 3. So that's going to be 8 times 3 plus 5 minus 4. It's going to give us 24 plus 1. And you can clearly see 25 is divisible by 25, right? We can take a 1 out of it. So therefore, P of 1 is true. Perfect. So we've started with that proof. The next part of mathematical induction is to assume that the function over here is true for a variable like pk. Yeah, that's what I want to do next. Assume this is true. Right, so we know from this is going to be 2 to the power of k plus 2, 3 to the power of k plus 5k minus 4 is divisible by 25. But how do we kind of write that in mathematical terms? The way I do it is I go 25 multiplied by m. That's just saying that this kind of number, I can always take 25 out of it. Therefore, that means it's divisible by 25. Right, and just specifying m would be a natural number as well. Yeah, so now we've proved that P1 is true. We've assumed PK is true. Since we're doing mathematical induction, the next step to go forward is proving PK plus 1 is true. Yeah, so this is going to be prove PK plus 1 is true. What I always like to start off with is a line that I like to call required to prove in mathematical induction. And I just write RTP, and it just tells me what is kind of my end goal of the proof PK plus 1 is true. And my end goal is to show that 2k to k plus 1, subbing n equals to k plus 1 plus 2, 3 to the power of k plus 1 plus 5 k plus 1 minus 4 is equal again to 25, and we'll give it a different term this time, 25L. Yeah, showing again that it's divisible by 25. So that's kind of the end goal. So let's get started trying to go from here to over there. Yeah. So what we're going to do, again, in a proof question, I always like to do the left-hand side equals the right-hand side rule, right? Want to get from here to here. So we'll start with the left-hand side. We have 2 to the power of k plus 1 plus 2 multiplied by 3 to the power of k plus 1 plus 5k plus 1 minus 4. Yeah, this is going to be 2 to the power of k plus 3, 3 to the power of k plus 1 plus 5k plus 5 minus 4. From here, what I'm going to do with mathematical induction, I know that I kind of have to use the assume PK from before. So I want to isolate something over here so I can kind of sub it in and prove that the entire thing is divisible by 25. And what I'm going to target over there is this term here. Yeah. So how am I going to do that? What I'm going to do is I'm going to split this guy up. 2 to the power of k plus 3 can also be written as 2 multiplied by 2 to the power of k plus 2. Yeah. And then 3 to the power of k plus 1 can also be written as 3 times 3 to the power of k. Yeah. And at the end, 5 plus 5k plus 5 minus 4, that's going to be 5k plus 1. Yeah. Now what I can do here is I can clearly see that grouping, right? These are all a multiplication of each other. I can see that 2 to the power of k plus 2 and that 3 to the power of k that I see over here. So I'm going to group them together, right? I have 2 to the power 2 times 3 at the front, and then 2 to the power of k plus 2, 3 to the power of k over there, plus 5k plus 1. From here, I can isolate this term out, right? I can use this to figure out how to like sub in the other term over here. right? So what's that going to look like? 6, right? 2 times 3 is 6 times, right? I know over here, from up here, that 2 to the power of k plus 2, 3 to the power of k is equal to 25m minus 5k plus 4. Yeah, just by doing some simple addition and subtraction. Right, so I use that to sub it in down here. That's going to give me 25m minus 5k plus 4 plus 5k plus 1. If I multiply that all out, that gives me 150m minus 30k plus 24 plus 5k plus 1. Yeah. If I just now group the like terms up, that gives me 150m minus 25k plus 25. And you see here, this entire term will be divisible by 25. I take a 25 out, I'm left with 6m minus k plus 1, right? So that will be equal to something like 25L, yeah, where L is just equal to 6m minus k plus 1. Right, so we've now proved that the left-hand side is divisible by 25, as we see down here. Now, different schools have different ways to write the concluding statement. The way I usually do it is just by saying, therefore, by principle of mathematical induction, so MI, Pn is true for all n natural numbers. Yeah, so this is the full working out for you guys if you guys wanted to take a screenshot.